Morning, everybody, and hope everybody's doing well for our webinar today. Today, we're going to be discussing extending the life of a spray booth and sort of some inspection items and some housekeeping items, as well as some potential upgrades for possibly some of our users out there that bought an entry-level booth, and maybe some of our dealers out there to just know that there are some upgrades available for different types of booths. So, again, my name is Trey Peavy, and I'm a product manager here at Colmet. So, just to kind of run through, if you're not familiar with who Colmet is, we manufacture in Rockwall, Texas, in our facility there. We invite anyone to come out and see the facility. We're proud of it. We think it shows well, and we invite you out there to see that. Within Colmet, we have three business segments. And one business is our core and catalog equipment business. The other is an engineered projects or engineered products group. And then we have our RP Filtration Products, which is a line that we brought in several years ago, and we manufacture those exhaust filters there. So to kind of talk through the core and catalog equipment, that's exactly what it sounds like, catalog equipment. These are pre-engineered pieces of equipment that run within a certain size range that we can get into manufacturing quickly. Some of these we may even have some partial builds in the plant of, but most of these kind of can bypass the engineering process and get a little faster through the manufacturing. And they cover a broad spectrum of industries and applications, from open front, bench booths, all the way up to large locomotive booths. These are what we would consider just a core, just a catalog type thing that didn't require an excessive amount of engineering or project management. On the engineered project side is that we're talking about things that are a little more involved, process systems, process washers and powder booths and ovens and dry off ovens and things like that are conveyorized, sometimes take a little more engineering up front. What we show you here on the screen is a project that we did for offshore oil rigs. That picture there in the center, that is actually a portion of an apartment complex that goes on those offshore oil rigs. That booth is several hundred feet wide, several hundred feet deep, and I think about 70 foot tall. So that one took quite a bit. It's blast and paint, and it's temperature humidity controlled. So you can see from the Colmet side of equipment that we can do the very simple things all the way up to very engineered, very complex type systems. On our third portion of our business is our RP Filtration Group. And we acquired this line from Research Products. A lot of people ask what RP stands for, and it stands for Research Products, who were the pioneers of the slit and expanded paper. So we took that, kept that initial in there from Research Products when we acquired that product line from them, and we did that in 2017. 2018, we integrated all into Rockwall, and here in the last year and this year, we've been really focusing on, growth. We brought on some filter specialists. We've created some new programs. One of those programs that we're really excited about that ties back to the sheet metal side of our company is our 5-year warranty. And we manufacture this filtration. We trust it. We know how it's put together, that we're able to say we'll give a warranty on our spray booths if you use this filtration and extend it 4 years to a 5-year total. So we're pretty proud of that, and that's how we were able to offer that 5-year warranty. So to give kind of a presentation overview here of what we're going to talk about in our presentation now. So all you that were timing me, you start your time now, right? So we're going to talk about just the function of a spray booth for those out there that maybe don't exactly know what it is. Its major components. We're going to concentrate a little bit on the exhaust system, talk a little through static pressure, ductwork, and some inspection of that. And then we'll just kind of talk about some spray booth upgrades that you may feel like really aren't upgrades. It should have came that way that first place, but it depends on the market that we're trying to touch. As you as an end user, what your really production requirements are, right? So there's always a dollar amount associated with the functionality of a spray booth or an oven or something like that. So we'll talk through some of those options, and maybe that could be upgrades and things like that for you in the future, or maybe now as you get back to manufacturing. So just to cover the ground rules, why a spray booth is required, right? is it's required to keep that atomized vapor in a certain area. We don't want a coating that has some types of a hazardous uh, chemical makeup to it, right? To just migrate anywhere it wants, get in the shop, touch personnel, things like that don't have the proper PPE. So the spray booth is designed to contain all of those vapors and inside that spray booth or the spray area, right? And it provides a clean environment. So you may be a user that's coating and you're not really worried about dirt or contaminants or things like that. You're maybe refurbishing rail cars, right? So you just, we got to get a coating on there. We're not really worried about if it's got a little dirt. But you may be making back pans for Tesla, and you say, I can't have any contamination, right? I can't have more than one contamination for every square yard of material, right? So a spray booth becomes more important to you and your production, and that's what they're designed for. And we'll talk through that some more when we talk about filtration and things like that. And also your code requirements, your national codes of OSHA, National Fire Protection, NFPA, they say that you have to have one. And, you're sort of caught by that. For us that sell the booth, we appreciate that, right? But pretty much all a spray booth has a work area where all that work is taking place. It's been designed for the work to be took place in that area so that we can draw those overspray vapors that we were talking about. You're going to have an exhaust chamber area that has some type of filtration on it, right? Part of that exhaust filtration is your extraction or your exhaust fan. It's going to have a motor. It's got to be ducted to the exterior of the building, out into the atmosphere is the way you would see 98% of these done. There are other configurations that can be done through, thermal oxidizers or even through like carbon filtration in some instances. But most of the time it's exhausted out into the atmosphere. And a spray booth, if you're talking about an actual booth enclosure, it can be open faced or maybe even open top or have open sides, or they can be totally enclosed. Obviously, the totally enclosed version is one that we can maintain a better cleanliness inside of the spray booth area. So another part of a spray booth that if you caught any of our other webinars, I've probably went into very in depth with a manometer, but it is an important part of a spray booth. And when we're talking about its performance and when we're talking about inspecting how our spray booth is working, what's happening is the manometer is our visual gauge that lets us know how our filtration is performing. Is it completely loaded? Is it getting close? Do we need to schedule maintenance to change out the filtration? And things like that if you keep that filter changed out, then that saves us down the line here when we go to talking about exhaust fans and exhaust ductwork, because you might have the right filter for the application, but if you don't change that filter as you should, it's not going to perform as it should, right? And you have operators that are spraying in a booth and they're not getting good airflow and they need to get parts out and they reach over there and they rip down a part of the filter to get better airflow. And now you're not filtering anything. And that is a real world example of what happens in spray booths when people do not replace the filters properly. So the manometer, right? Everybody kind of understands how it functions. As your booth comes on, you get a set level for your clean filter. As your booth runs up, you're going to see somewhere where that filter loads out. If you don't know exactly where that is, I welcome you to go and look at some of our YouTube videos where we actually talk about a manometer and setting up a manometer. We have some airflow videos as well. And then we have another webinar that we've done that goes a little more in detail with that. So I just encourage you to reach out to those resources and get more information from that. And when we're talking about a design of a spray booth, they're typically designed, by the direction of airflow. Very simple, right? We're looking at, you have a cross strap where the air is predominantly horizontally moving across the work area. Then you have a downdraft where it's mostly moving down. Now, you have side downs where it moves down into the sides. You have modified cross drafts where it comes in the top but pushes down low but moves through the booth. So the majority of the airflow is kind of how it's designed. Each one of these booths have different performance characteristics, with the type of coating and things like that. And that's why we use different types of airflow in those booths. Some other groundworking here when we talk about booths and their design and things like that is they're designed to move a certain amount of air to meet the standards of the code, right? So if we look at where OSHA 1910 says that we need to have a minimum of 100 linear feet per minute. You're like, Trey, why is this important for me if I'm doing inspections? Well, it sort of goes back to our manometer reading, but if you were inspecting your booth, say once a year or biannually or something like that, then you need to know and confirm that your booth is moving the airflow it was designed to move. This is a step that needs to be done as soon as the booth has been erected for the first time. And that way you have that baseline and you know that our booth is performing as it should. As the booth ages and you keep performing these tests, if it starts to degrade in its airflow, then you're gonna know that, hey, we need to do something. Something's happening. And we'll talk about some of those reasons here. But that's why it's important to understand how the booth was designed originally and why it was designed for that. And then as you're moving through from like I say, a new booth to a 2 or 3 or 5 or 15-year-old booth, you kind of have a baseline that you would go on there. So if you're looking at the airflow in the booth, I talked about that. We have a YouTube video. I've actually talked about it in depth through a webinar as well. But what I'm saying is we want to measure that airflow in the booth when it's clean, and we want to make sure the booth is balanced to however it's supposed to perform for that. You can use an anemometer, hot wire, some type of velometer, whatever it is that you have handy for you. Just make sure that it is rated for the range of velocity that we're looking to see, which is going to be somewhere between, say, 100 and 3 or 4, maybe 500 feet per minute. If you have a device that's set to run at 10,000 CFM down to 100, but it goes to 10,000, that sweet spot is going to be somewhere around 5,000. So if it's not around there, you're going to get some deviation as you go lower or higher from that. So you need to find a gauge that has a lower range because honestly, guys, 100 feet per minute or 300 feet per minute is not an extreme amount of air velocity, okay? So you have to be cognizant when you pick your gauges that they can get down there, that low. But moving through, what I like to do, we talk about airflow, is measure it at the filter face. That's I feel the most accurate way. All the air going out of the booth is being done through the filter face. And then you just calculate that airflow. And then, like I say, you want to repeat these until you're not seeing them achieved. That's when you're setting a manometer. Or when you're doing booth inspections, if we're not achieving those 100 feet per minute with clean filters, then we got to start digging a little deeper and looking into other items, there. So if we talk about the ductwork and ductwork inspection, so the filtration is very important to keep our extraction equipment clean and performing accurately. I mean, it does. We do want to use it to keep that vapor and those particulates from getting into the atmosphere, but depending on the coating, it can be very detrimental to the actual air moving equipment itself, right? So in the design side of this thing is we have to be cognizant and understand our ductwork configuration. If you've watched any of our other webinars, we're talking about building spray booths or maybe putting them in certain applications or something like that, this has always been said. Figure out how the ductwork has to be run because you need minimal offsets. The more offsets you put in the ductwork, the more transitions and things like that, the more static pressure you put against the fan. If we design for that at the beginning, then that's okay and we can work through that. But by not doing that, and I bring that up because a lot of times guys have booths that they want to move, right? So you have some older equipment we're looking to move them to a newer facility or move them across the plant. And when they were originally designed, the ductwork was very streamlined, right? Maybe it had one offset, like our picture to the right corner. And it just had that one offset in the ductwork. Everything is at least three diameters away from the fan, so we know that we're getting good laminar airflow. So, but we move it somewhere else that's got an overhead crane or something in it, and we're having to change our ductwork configuration. Well, by doing that, you've just completely changed the way the booth was designed to function, right? So when we're doing our inspections of our booth and things, it's just not going to perform that way. Now, there are a couple of ways to check the exhaust filtration for overspray or something that maybe is going wrong from the outside, which would be go through the inspection hole in the clean out, and that should be mounted right above the fan in the ductwork. You know, that lets you look at the fan and see if it has buildup. You know, a fan that sees overspray will generate, you know, buildup. Now, it does take quite a bit of buildup on a fan to really start affecting its performance. But the worst, now, you know, if it gets around a 1/4 inch, then we start seeing substantial drop. But mostly it lays a very nice, you know, thin layer of coating of overspray that builds up over time. The worst thing about having your overspray on your part or your fan is that if it breaks off. If it breaks off of one blade, then it throws the fan out of balance, which wrecks the bearings, maybe bends the shaft, right? It maybe chips off a blade. That's very costly because, you know, we won't sell you just a single fan blade. We'll have to sell you the whole assembly because they're balanced. And that's very important. When you buy a bearing, sometimes you have to buy the shaft to go with the bearings. So you're almost at that point buying a new fan, you know, and then you have the install cost and the downtime and things like that. Another way to inspect your chamber is when you're changing out your filter medium. Look in the filter chamber, see what it looks like in there. You can look up through the stack possibly, you know, and get an idea of, is our filtration proper? Is it been installed properly? You know, what's going on? Because to give you just some visual examples of what I'm talking about, you see the picture to the left of a fan that's got some overspray, you know, on it. Yeah, it's not the best, but the fan looks like it would still perform fairly well with a minimal amount of cleaning. You see the ductwork that's attached over there. There's an excessive amount of overspray, right? And that's a straight piece of duct. So you can think that any transition in that ductwork or anything like that actually looked worse than what we're seeing. That's important to a fan because as the duct diameter changes in size, you know, if you look at that image there, let's say we got let's say we got an inch of buildup, right? So we've lost 1 inch diameter all the way around that pipe. We've a 1 inch annulus of duct, right? So you can say we've lost 2 inches in diameter because of that. Well, that increases our speed through our ductwork. That increases static pressure. That gives us, our fan, less ability to move the CFM as it was designed for, right? Less time to do filter load. When you run multiple ducts into a single piece of duct, you know, there is a lot of, this happens out in the field all the time. Guys just want to have one penetration, but you have to figure for those things. And that's where moving duct comes into play. And then my all-time favorite piece of ductwork is over on the right-hand piece of the screen. I love this because this was a booth that was sold without anyone thinking about where it was going to go. And actually inside the room, you can't see through this picture, is 3 90s where the ductwork is running horizontal and to the booth. So you had a fan and it turned 90 directly out of the fan, which for all of you that know, that is a no-no, right? You need at least 3 diameters before you transition from that fan. But that is what happens when we don't plan well with our ductwork, right? So kind of talk about through some of our filter and inspection of our filters. I don't know what your booth has in it, right? Hopefully, you know, you're using our media, but there's other medias out there. You have depleted cardboard, fiberglass, paper slit, you know, that's our product, is slit and expanded, and then you just have just straight polyester, right? So, there's a lot of filtrations out there and a lot of coatings and things like that. But the main thing that you have to understand when it comes to filtration is that you're required by code to have a 98% arrestance on that filter, right? And that's done with a test that requires it to be sprayed at a certain volume with a certain type of paint to meet that 98. And that certain type of paint is a Sherwin-Williams permaclad bake-on enamel. Okay, so it's pretty sticky, high viscosity. It's honestly kind of hard for a filter not to get close or be 98%. If you're spraying a clear coat, right, and let's just go crazy with it, and let's say you're spraying a clear coat with a Bell atomizer, right? Well, that efficiency of that filter is probably below 50, maybe around 40 at that point, because our particulate curve is so low, right? Our size, we're able to shear that clear coat because there's no color pigmentation. We're able to shear it easily, make it smaller, micron sizes of particulate. So it's harder to catch when you're spraying something out of a conventional spray gun that's a very high viscosity, a bake-on enamel. We're throwing a lot of rocks and marbles at it, I like to say, and we can catch that. So it's important to understand where that efficiency plays into this. This is a big eye chart that I've been showing you while I'm talking, but it kind of just breaks down. And if you had a booth and you were spraying so much, at 98%, you would lose almost a pound of paint in a week through the exhaust system. If you had one that was 99.5, let's say, which is where most of our slit and expanded paper with polyester filters run or start at, 99.5, then you're only seeing about a quarter pound after that week that actually got through the media and possibly went into your extraction system. Or if you're running a two-stage, actually saw the second stage, right? So if that makes sense to you. So just to kind of talk about our own filtration a little bit, because I talked about that, the slit expanded paper, it's made to be depth loaded. It's not a fix-all media. It's not going to cover 100% of every coating, every application, but I'm going to say it's going to hit 85 to 90% of those, right? So we have a lot of different models available. A lot of people say, well, I tried a paper filter and it didn't work. Well, which one? Well, I don't know. It's paper. Well, we have a lot of different models with different paper layering. Some have polyester. They're all designed to do something a little different. If you're spraying, a certain type of viscosity coating, then we have certain filters that perform better, for that. So, if we were throwing, a water-based stain or something like that, we would need to see something with some very good filtration on the polyester side, right? And maybe we need a dual layer of polyester. So where if we were spraying, something that was just, say an epoxy or something like that, we may not need that much filtration on the back end. So there are different models and different things to do in that. And our W series product is our 5-year warranty. It's engineered the same way. We actually use a virgin polyester, a very high grade polyester compared to our other filters, but still slit and expanded paper, runs the 5-year warranty. We set it up kind of the same way for the different types of coatings. We're just, we're able to cover a broad base on that. So one thing we talk about when we talk about upgrades is we've done some studies, and we've seen a lot of spray booths go out with 20 by 20 filtration. And if you're talking about a 20 by 20 grid pad that goes on the wireframe, right? Colmad has manufactured booths for years and years where that was the standard. Now Colmad has a standard is using blanket material, mostly because it is, it is faster for changeouts, and a customer or an end user actually spends less money over time because of that. We have a new filter lock system that we send out with our blanket media. And the cool thing about this system is, and where it actually benefits over the 20 by 20 pad, is that we're able to encapsulate 100% of that blanket media. So any air that goes into our extraction system has passed through the media. Okay, so we've given it an opportunity. How many of you out there have walked into booths and there's just gaps in the corners where they hung a blanket and it didn't cover everything, or it's too long and it's running across the floor, and even when the fan's on, it's still a gap. Well, air takes the path of least resistance, and that means that air is going to go through that opening. Now, when the filters are clean, yeah, it's going to stick to the filtration because that may be the easiest for it to, instead of changing direction and going through that hole. But as those filters begin to load, that's exactly where it's going to go. And I hear this all the time when we talk about types of filtration, and you talk about like a 15-gram fiberglass, right, which is a very inexpensive filter, which is very inefficient, to be honest with you. And they go, well, these filters lasted way longer than yours did. Well, yeah, because they weren't filtering anything, right? I can read the newspaper behind a 15-gram fiberglass, so I doubt it was really catching overspray, right? I mean, an overspray has to be close to like 60 to 100 microns, somewhere in there, for you to even see it with your eye. So how many particulates are in the air that you don't even see? Well, that filter is not going to stop those, right? So that's where the filter lock and all that kind of comes into play. It helps bring in those gaps, because a 20 by 20 pad, even installed properly, has potential for 20, 40, 60, 80 linear inches per pad for bypass, right? So with the blanket system, you see, we're going to close in that whole thing. There's no place for bypass except through that. So that's an upgrade that you can consider. Moving with your booth, the filter lock system will install to our competitive booths as well as our booths. It's a very simple design that just fastens to the sheet metal. As long as there's a flat surface, at least 3/4 inches wide, we're able to apply the filter lock track. Through, like I was telling you on the roll media, just to kind of give you some more information here, we allow to seal that booth up completely, and you're gonna decrease about 60%. I talked about the time change being a lot faster. You can check our video out where we actually time this. We just pulled off and replaced pad filters, and we pulled off and replaced blanket filters and timed them. So, and we do have some webinars where I go through the math and some different examples of where that plays out. But lower operating costs, that's going to give you more production time, right? If it took you 45 minutes to change out filters before, and now you can do it in 5 or 10, you're back doing more production, right? If you can settle into a better filtration, then you can get better, longer production time, and you're even getting out more production, right? So all that just equates to more finished products a day. To talk about some other upgrades for some of you out there that may have or non-pressurized booths, would be to totally enclose one and use intake filtration. Intake filtration is used in enclosed booths so that we can control how much contaminant from the shop or from outside is getting into the spray area. Okay, so we sell these filters as well, and a lot of times they don't have a manometer hooked to them in a lot of instances. Now it can be done, and I recommend that, but you're servicing these about every 6 to 12 months, depending on your environment. If you're using a pressurized booth with an air makeup unit, that air makeup unit has intake filtration as well. You're probably going to see a lot longer life out of your intake media. If you have a non-pressurized booth that's using intake filtration, and say it was enclosed, but it's what we would call non-pressurized, then they're probably not going to last that long, because your booth is in essence a vacuum that's sitting over in the corner of your plant, and it's just pulling everything to it. So these filters are catching all of that and everything. So they probably will, load out a little faster than 6 months. But these are panel filters, so they have a wire grid inside of them that supports them. They're different than the exhaust pads that you have to stab onto the filter rack. So you got a tackifier on the second layer of this. And while we're talking about it, we'll talk about the installation of these, because sometimes there's some confusion. The filters that we sell are white and green, and the green side has a tack to it. The main thing when you talk about filtration, any filter, unless it's completely made of one layer, one denier, or anything like that, it has to be filtered from the large to the small side, right? So we want the more open side of that filter, which in an intake filter would be the white side. On an exhaust filtration for a split expanded paper would be the paper side, because that's the wider side. That gives us the opportunity to catch those rocks and marbles that we're throwing onto a surface that can handle catching those, right? The tacky side of an intake filter is our finest filtration size. And the reason why you put that tack on there is that tack is there to catch those very, very small microns, the ones that aren't large enough to carry enough inertia to impinge themselves onto the filter media, right? They're the ones that are floating around through the air, through the filter, bouncing from place to place because they're so small, and they may get intercepted by the media, they may not. And when we're talking about intake filtration, we're normally talking about dry particulates. So we need something that's kind of tacky that'll reach out and grab that. When we're talking about paint and liquid paint characteristics, a lot of coatings, that overspray is actually wet, so it'll help stick itself to our media. So that's why you see that. So the tacky side of that filter, in essence, if it was an intake filter, would be inside the booth. Okay, it would not be turned up into the plenum. If you do that, now you're catching those larger particulates on your fine side, and you're just going to blind out your filter a lot faster than it needs to be. So I don't know which one of you out there needed to hear that, but I hope it was good for you. The another upgrade that we're really excited about here at Colmat is LEDs. We've been producing LEDs now for several years, probably going on about 10 years now, but we've created a new light, and it's called the E-Light. It's a lot smaller than our original light. You can see from the picture in the right, our original light versus our new light. We frosted the glass in there and things like that. But when you go from LED or fluorescent to LED, you're looking at a lot of energy savings. I know there's some of you out there that have older booths that maybe still have T12 bulbs. You're talking about a bulb that's using more than 4 times the amount of electricity than what our light is using, and we're going to produce more light than what those T12s probably ever did, even when they were brand new. So these things are easy retrofits in the spray booth. They can be ordered with the LED lights, and they can be retrofitted. We have retrofit panels that'll hook them to our light fixtures as well as any competitive light fixture. And we can put these lights in any of our competitive booths as well. We just need to know the light size and what we're trying to replace with them, right? One of the cool things about these things is there's no lens switch. If you're ever familiar with installing a lens switch or what that was, it's required by UL listings that there had to be a switch in case the glass was removed, because it was made to be removed from the inside of the booth. And it just guaranteed that the cover got put back on. It isn't a glass break sensor. The code doesn't require it to be such, but it just means that since the light was maintenanceable from the inside, you have to have something that says, hey, it got put back on. Those become costly in installation. Sometimes they're a little finicky getting one of them to work. You don't necessarily know which one in the chain isn't working, and they're hooked to your application equipment so that you can't spray if this isn't working. So with our new E-Light design, what we've done is we've created a maintenance-free light fixture, and this light fixture carries a 5-year warranty by itself. So if something happens to it, you say, I can't maintenance it, it's got a 5-year warranty. So, just you'll send us that light, we'll send you another one. And but LEDs are very robust. They're generated to move at like 25,000 hours before they even start to degrade really in their activity. The LEDs don't last forever like some people think, but they don't degrade to the point that fluorescent does. And our lights are designed that we can actually lose 5% of our diodes and still be able to produce the amount of light that we had it designed for. So the fixture is rated for Class 1 Division 2, Class 2 Division 2. It can go anywhere on a spray booth it needs to. It can be next to an opening It can go anywhere around the exterior of the spray booth that it has to happen. So that's a great upgrade there. I may mention to you guys that maybe have some of these old booths with T12 light fixtures. Just want to run you through this real quick. But if you had a 1980s rail car booth, there's your dimensions. You're running, like 102 fixtures, there to make that booth work with T12s, had 4 bulbs in there, right? And we've all seen this, and we all know that these booths exist. And what you'll see there, if we kind of look down at the math here, is I'm just looking at energy here. And if you take your 160 watts per fluorescent light, right, and yet each ballast has 24 watts, you got to get 184 watts, right? Where our light fixtures over here, that the 4000s are producing about the same as that T12, and they're only 33 watts. Okay, so you can see that there is a substantial savings. We can, because our lighting output, we can produce more light. We can actually eliminate some of the light. So if we did this booth today, or if we retrofitted this booth that we're looking at, it has 66 4000s and 36 8,000 lumen lights. And you say, okay, well, what does that really mean? Well, that really means a cost savings of $9,000, dollars a year. So, you're going to have a first year cost to upgrade the light fixtures, but your next year, you're going to save the delta of whatever you didn't spend, and the next year you're going to save $9,400, and the next year it's another $9,400 because that booth was always pulling that energy that you didn't know, right? So LEDs are a great way to get a booth kind of modernized and save a lot of money, especially if you have a larger booth. If you have a smaller booth, it's hard. 1 or 2 lights, you're not going to save a whole lot, because you're just not using as much electricity. But it still will save you money. But there's some other opportunities for retrofits as well. Other than just the energy reduction, it's the maintenance cost. You're not replacing bulbs. You don't have flickering bulbs in the light booth. Your improved light quality has got better. We have better light distribution. Like I say, they're not flickering. They're not degrading. Because a fluorescent bulb begins to degrade as soon as you plug it in at a way higher rate of loss than what you would see through an LED. LEDs are green technology. I don't know if a lot of you know, but you can't just throw a fluorescent bulb in the trash. That bulb has to be handled by a hazardous, disposal because it does have mercury. So I know a lot of people maybe don't know that, but those bulbs can't go in the trash. And then with the LED too, what you'll see is that your lighting temperature is a lot better for what we do in our spray booths and our coating environments. Your T12s and your T8s, even a lot of times you go to Home Depot and you buy bulbs and they're a soft white or kind of a yellowy white light, then your temperature range is just too low. If you want to know more about the LEDs and things like that, we have some sources for that on our webpage, YouTube, other webinars, things like that. I hope that's an upgrade. Now, an upgrade that a lot of people don't think about, but we talked about cleanliness of our booth, right? And I want to throw in air makeup units. Not only are sometimes air makeup units required because your booth is moving too much air, you have to be able to withstand certain code that says that, I don't remember the verbiage right offhand, but if you're moving so much air per volume of your booth, you have to have some type of air replacement. Now that AMU could be on the booth, it could be blowing into the room, or you could use, like, say, an ambient fan. So it depends on what you're really trying to do. But AMUs can be retrofitted to booths to be able to give you a cure cycle. They're able to give you a consistent temperature. You guys in the north, when it's wintertime, it's hard to spray in a booth when it's pulling air from outside, right? So you have an air makeup unit. We have an opportunity to heat that air up and get it more conducive to where we want to be, when we're spraying. The AMUs can be orientated probably any which way we need to make sure that they get in your installation right. So a lot of times an air makeup unit can be used just to dump into the building. and we call that a demand unit. If you had a woodworking shop that has 5 or 6 open front booths in there, and you would set an air makeup unit up in there that just blew air into that environment. And when we know how many booths are running, then we know how fast to run the unit. Now, some units are controlled with pressure switches and things like that, but that becomes very tough if doors are open and it's hard to hold the pressure. So if we know these kind of things at Coolmat, we design the units to run at different speeds based on how many booths are actually in operation. So air makeups, you have the ability to recirculate air. This is really beneficial when you're curing parts because now you're saving that energy. You've already heated the air once. You bring it back through, you just reheat it slightly to maintain that temperature. So, and you also do have the ability to do actual temperature control and humidity control if we wanted to cool the air, to a certain point. We talked a little bit about the discharge units already. There's prep mode, things like this that are really a lot of upgrades for your booth. A gun hook. You don't think about it, but let's say you're painting something and you have a lot of little prep time or some inspection time. Well, your booth just sits there and runs wide open while all that's happening. We can integrate gun hooks and things like that into our system where when your painters hang their guns, the booth goes into an economy mode or like a prep mode. Airflow slows way down. And as soon as the gun picks up, it ramps back up, and it's ready to go. So, that's a pretty neat option when it comes to, upgrades and things like that for your unit. AMUs run on propane natural gas. The inlet pressure can be variable. If you don't tell us, we say it at 2 inches, just because that is the most economical valve train. If you go a lower pressure than that, the valve train has to get larger, which causes, a little more money. So that's set that way. So if you got something that's a little different, that's not a problem. If you have an open front booth, right, and you're like, man, I really do have a contamination problem, I need to be able to control that. You can do that with doors. The construction of most booths, you can add an extension, let's say, because most time you have an open front, you have the minimal amount of work area you need. We added, 5-foot extension, and we put doors on it, add a couple of LED lights to it, and then boom, now you have an enclosed booth that can filter out that contaminant. If you want to take it a step further, we can introduce pressurized air into the booth, which is very beneficial, again, when we're talking about controlling the cleanliness of our spray booth, because then we're also able to be slightly positive and may push a little air away from the booth, right? Even if you're not positive and you're running at 0 inches of water column, which just means the amount of air I'm putting in the booth is the exact amount of air I'm taking out, I'm not drawing dirt from my shop to my booth. If you think of a body shop, they're bondoing right over here left of our spray booth, and then we're painting right there. We don't want all that Bondo dust getting into our spray booth. So we need a pressurized booth so that we can, even though we're exhausting, 16,000 CFM or 20,000 CFM, we're not moving the environment of the shop around because we're introducing 16 or 20,000 CFM into the booth. So it's just moving what we're giving it, and it isn't dragging all that around to you. So doors are an option to move forward. So I know I laid a lot on y'all, and I feel like I spoke really fast to get that information out to you. But when you're talking about spray booth inspection, just to recap, you got your exhaust stack. You can inspect the exterior. What's the offsets look like? Can we straighten that up any? Because your booth will perform better. What's the inside look like? How much overspray do we have in it? Our exhaust fans the same way. Our filter media, are we using the right filters? Are we changing the filters when we need to, right? On your upgrade side, I highly recommend going to the filter lock system with blanket media. That'll save you a lot of labor time and possibly some issues in the exhaust system with overspray. We have the LED lights, air makeup units, and booth doors are all great upgrades, for our spray booth. So I mentioned several times our YouTube. We have a lot of things on there. I really, really reach out for you guys to get out there and look at those. Right now we're all still locked down. I know some of you may be moving around more, but because of the COVID, we're still locked down. So this gives you an opportunity to still get some education in on some topics that you may be like, hey, I already know that, but just go ahead and watch it anyway, because you might learn something that you didn't know before. And maybe not, but I hope you do find it worthwhile. So Judy, I'll go ahead and open it up now for any questions.
All righty. Thank you, Trey. All righty. We do have a few questions. First one is if we have a customer that's using polyester filters and they have to change every day due to face loading, would the RP filter media work good for fast drying catalyzed coating materials?
I was struck to say yes. The problem with polyester is the way that it does filter. It is a more efficient media. Even when you have large denier and you try to open that denier up, it's very it's still very efficient. So with the RP design with the slit and expanded paper, we're able to create a baffling system with that paper before it hits the polyester. So what we've done is and the design of the paper is kind of neat, and the way it works, and I don't even know why it does, but as it starts to get loaded and kind of gets wet from the overspray, it starts to expand and increase kind of in depth, which kind of opens itself up, let's say, so that it can keep loading. So I would have no doubts that our filtration would probably perform very positive in that type of environment. Where we've seen a lot of fiberglasses and polyester's face load, our type of filtration really performs strong in that type of application.
All right. Thank you, Trey. Next question, can I install the E-Light LED lights into a competitive spray booth?
Yes, you can. So all we would need to do is have a retrofit panel, and it's just a piece of sheet metal in essence that our light bolts to. And then depending on the competitive light, is it a bolt-in design? Is it a slip-in or whatever? We would just design that retro kit for that particular light installation to put those lights in.
All righty. Thank you. Next question. How would a demand type air makeup work if I had 3 booths that are intermittently run?
Okay, so the way that can be done 2 ways, right? Like I mentioned, it can be done on building pressure, where let's say if we had a perfectly closed up room, the air makeup was blowing into that room and those 3 booths were in that room. When all 3 booths are running, there's a certain draw against the room, right? Because we're pulling air out, and the air makeup can sense that and speed up and maintain the balance. But if someone opens the door, our pressure goes away, and all of a sudden our air makeup runs away from us because it doesn't know what happened to the pressure. Now, by doing it where we monitor how many booths are running, so they're all wired back to the AMU, and the AMU has a variable frequency drive in it. And when one booth is running, we spin the fan at the speed we need to move that amount of CFM. When the second booth is running, we spin the fan faster so that we can generate that much CFM, and so on and so on. Now, when the more booths we put in the line, it's possible we may have to have 1 or 2 air makeup units because a fan only has so much, it's called a fan curve. Its performance can only go down so low and go up so high within a certain horsepower speed range. So, but that's how that would be done.
All right. Thank you, Trey. We have one more question. Do you make your roll filter replacements where they can be retrofitted into a competitor's booth?
Yeah, so on the RP side, we are limited in width to 45 inches, which would cover 2 20 by 20 sails of 40 inches, and we can make whatever length we need. So the only thing that we need to do when we retrofit is just figure out is any additional brackets or anything like that needed for the filter lock system. If you were just saying, I just want to hang blankets in a competitive booth, then they would just overlap, which can definitely be done.
All righty. Thanks, Trey. I think that's all we have. Would you mind just going to the next slide, please, so we can just do a few little wrap-up items here?
Yes, ma'am.
As we mentioned, here's just a Comet who to call list so you know who to contact if you have any questions about any of these upgrades or anything, that any type of inspection in your booth. This is our direct sales force. On the left, you see the pictures there with the contact information, and on the right is a map just to familiarize you with the rep in your territory. Next slide, please, Trey. As Trey had mentioned, the Comet website, we have a lot of information besides the literature and stuff. I also mentioned that there is an area there in the resources area where you can go ahead and sign up to register and attend one of our webinars. And the next slide there, Trey. This is the next upcoming classes. So our next class will be alternate spray booth designs, thinking outside the box, which is a really interesting webinar, so you may want to sign up for that. And then on the next slide here, throughout the presentation, Trey had mentioned many of the videos that we have. We now have about 27 or 29 videos on the Comet YouTube channel. So it's a great resource, especially when you have new people joining your company. It's a good way to get touch base on a lot of the different items here we've talked about, all different facets of the types of equipment that Comet makes. So it's a good resource tool to go to. And then I just wanted to mention one more thing too, is remember, don't forget to download your handout before you leave. And then about an hour after the presentation ends today, you will receive an email thanking you for attending. But also in that email, there is a certificate of attendance. Please make sure you click on that and download your certificate showing that you attended today's webinar. And I think, wait, we may have, no, I think that was a hand raised. I think that's it. That'll conclude our webinar today. I'm sorry we ran a little bit over, but we do appreciate your time.